Hey guys, welcome back to my YouTube video. Today we're going to talk about the sun. Sorry guys, this is not the sun we're going to talk about. This is the newspaper company. The sun that I'm actually going to talk about is this sun, our sun. The sun that's in the middle of our solar system. But before we continue guys, in this presentation, some images you might find very disturbing because it contains very graphic images. So if you are easily disturbed, then I recommend that you turn off this video right now. So turn it off right now, and so if you're going to keep watching, let's continue. Okay. So what is the sun? First of all, the sun is a star at the center of the solar system. It is a massive hot ball of plasma inflated and heated by nuclear fusion reactions in its core. So next, Sun is a G-type star. The Sun is a G-type main sequence star, informally called the yellow dwarf, though its light is actually white. So the light that we're all getting from the sun around the world, as you probably noticed, is actually very white, but it's actually classed as yellow dwarf. So it formed approximately 4.6 billion years ago from the gravitational collapse of the matter within a region of a large molecular cloud. Sorry, guys. So this is the basic details of the sun. So now we're going to talk about the features of the sun. So we're going to talk today. We're not going to talk about all of it. We're going to talk about the flares, the chromosphere, photosphere, sunspots, and of course the corona. So first we're going to talk about the corona. So the corona is the outermost layer of a star's atmosphere. It consists of plasma. The sun's corona lies above the chromosphere and extends millions of kilometers into outer space. It is most easily seen during a solar eclipse, but also observable with a coronagraph. Spectroscopic measurements indicate the ionization in the corona and a plasma temperature in excess of 1 million kelvins, much hotter than the sun's surface of the sun, known as photosphere. So the corona is the outermost part of the atmosphere of the sun. This is the photo of the sun when the moon has sitted is directly in front of the sun, causing a shadow of the total solar eclipse. And during a solar eclipse, we can see the corona going around the sun. Next, chromosphere. A chromosphere is the second layer of a star's atmosphere, located above the photosphere and below the corona. In the sun's atmosphere, the chromosphere is roughly 3,000 to 5,000 kilometers, which is roughly about 1,900 to 3,100 miles in height, or slightly more than 1% of the sun's radius at maximum thickness. It possesses a homogeneous homogeneous layer of the boundary with the photosphere. So this is the chromosphere, guys. We're not going to talk too much because this is a very big presentation, so I don't want to keep you guys waiting a lot. So moving on now. So next, photosphere. So photosphere is a star's outer shell from which the light is radiated. The sun's photosphere has a temperature between 4,000 to 6,000 degrees Celsius, with an effective temperature of 5,500 degrees Celsius and a density of about 3 times 10 kilograms per cubic square meters. No, sorry, cubic meters. Just cubic meters, guys. Sorry. God, it's so hot today. I do apologise. We had a very hot weather today, and yeah, and it's extremely unusual for October to be 32 degrees in Turkey. So yeah, so moving on now. So increasing with the depth of the sun. Other stars may have hotter or cooler photospheres. The sun's photosphere is around 100 kilometers thick. So this is the bottommost part of the sun surface, photosphere. In the middle we have chromosphere, and on the top corona. So next, solar flare. Now, as you can see on this picture here, this is the solar flare in size compared with the Earth. Very big, guys, really big, extraordinarily big. So a solar flare is an intense, localized eruption of electromagnetic radiation in the sun's atmosphere. Flares occur in active regions and are often, but not always, accompanied by the coronal mass ejections. Solar particle events and other solar phenomena. The occurrence of solar flares varies with the 11-year cycle. Solar flares are thought to occur when stored magnetic energy in the sun's atmosphere accelerates charged particles in the surrounding plasma. This results in the emission of electromagnetic radiation across the electromagnetic spectrum. So guys, the solar flare is, as I said, is made out of radiation. It of course tosses out into the atmosphere, and sometimes they can reach towards Earth in a solar wind, as a solar wind. So high energy electromagnetic radiation from the solar flares now we're going to talk about. So high electromagnetic radiation from solar flares is absorbed by the daylight side of the Earth's upper atmosphere, in particular the ionosphere, and does not reach the surface. So you don't have to worry about this, guys. Nothing will happen to you if the solar flare or wind does reach us on Earth, because it cannot, because of the magnetic fields on our planet. The solar radiation cannot reach us on the surface. The absorption can temporarily increase the ionization of the ionosphere, which may interfere with short-wave radio communication. So guys, it can interfere radio signals. For example, I have a radio right here. If the solar flare does reach Earth, it doesn't hit the surface and damage us, of course. that won't happen, but it can interfere the shortwave radio communications or any other radio signals that are out there. So next, sorry guys, it's so hot today. It's really annoying. So I'm trying to keep things cool, but it's quite unbearable today, especially with all this humid and that. So flares also occur on other stars, where the term stellar flare applies. So you're looking at the stars in the night sky. All these stars you see are in fact other suns that are rotating around the galaxy in our universe. There are about 340 billion stars or suns in our galaxy, and all of them can also throw out, well, not all of them, I'm guessing, but most of them can throw out flares too. So, next, the sun's core. The core of the sun is considered to extend from the center to about 0.2 to 0.25 of solar radius, which is about 140,000 to 170,000 kilometers. It is the hottest part of the sun and the solar system. It has a density of 150 grams per cubic centimeters at the center and a temperature of 15 million degrees Celsius. That's about 27 million degrees Fahrenheit. So that is a little bit hot, guys. At least it's not this hot here where I am, but I am sweating like mad actually. So I do apologise for keeping on stopping and that, but it's really annoying. So yeah, 15 million degrees, guys, in the core of the sun. The core is made of hot, dense plasma, ions and electrons at a pressure estimated at 2.65 times 10 pascals or 265 million bars or 3.84 trillion pounds per square inch. So it has a lot of pressure inside, guys. Due to fusion, the composition of the solar plasma drops from 68 to 70% hydrogen by mass at the outer core or at the sun's center. The core inside is 20% of the solar radius, contains 34% of sun's mass, but only 0.8% of the sun's volume. Inside the 24% of the solar radius is the core, which generates 99% of the fusion power of the sun. So now we're going to talk about the sunspots, the spots that sometimes appear on the sun. Sunspots are phenomena on the sun's photosphere that appear as temporary spots that are darker than surrounding areas. They are regions of the reduced surface temperature caused by concentrations of the magnetic flux that usually in pairs of opposite magnetic polarity. Their number varies according to approximately 11-year solar cycle. So every 11 years the number does vary of how many sunspots there are on the sun's surface. Individual sunspots or groups of sunspots may last anywhere from a few days to a few months, but eventually decay. Sunspots expand and contract as they move across the surface of the sun, with diameters ranging from 16 kilometers, just 16 kilometers, guys, very little, to 160,000 kilometers. So a lot bigger than Earth, guys, a lot bigger than Earth. But whenever a sunspot appears on the sun that's the same size as Earth, it will look like this big, guys. Just this tiny little bit here is actually the size of Earth. So if you want to look at the sun through telescope or naked eye, you have to have a shades on them. It is required, you guys, because if you try to look at the sun without using any shields, you'll get blind straight away. Of course, larger sunspots can be visible from Earth without the aid of a telescope, but you need a shades to wear them. Sun shades are strongly required for looking at the sun with or without the telescope, because you will end up getting blind permanently, guys. You will get blind pretty much straight away. Your eyes will be toasted, it'll be burnt, you will be blind for the rest of your life. So please use the sunshades when you're looking at the sun, whether there's a solar eclipse or you want to see sunspots appearing. It's required, you guys. So part of the internal energy is emitted from the surface as light, ultraviolet and infrared radiation, providing most energy for life on Earth. So the sun gives us light, it gives us the ultraviolet, the UV, and it gives us infrared as well, guys. So what is light? So sorry I seem stressed, guys. Trying to do this video while it's so hot is unbearable. Do apologize once again. So light is electromagnetic radiation that can be perceived by human eye. Visible light is usually defined as having wavelengths in the range of 400 to 700 nanometers, corresponding to frequencies of 750 to 420 terahertz, between the infrared with longer wavelengths and the ultraviolet with shorter wavelengths. So what is ultraviolet? As you can see on a scale, not very far from the visible light. The ultraviolet is a form of electromagnetic radiation with wavelengths shorter than the visible light, but stronger than X-rays. So a lot stronger than X-rays, guys. UV radiation is present in the sunlight and constitutes about 10% of the total electromagnetic radiation output from the sun. So most of us probably know that the X-rays can actually give us cancer on our skin or anywhere in our bodies, because X-rays also contain radiation. But the ultraviolet, the UV, is actually slightly more powerful than the X-rays. So this is why we get a lot of sunburns on our skin. because it's not caused by light or heat. It's all caused by ultraviolet radiation, which is very dangerous, which is why we have to wear sun cream every time we go out in the hot weather. If you want to live longer, not just getting burns, you can actually die from it. So I must warn you guys one more time. There are a few graphic images next, which I'm going to show you what the ultraviolet can do to your skin if it's not protected by suntan, for example. So if you're really easily disturbed, you guys, turn off the video right now, because I'm going to bring up these 3 photos. Okay, so 3, 2, 1. There you have it, guys. This is what the ultraviolet can do to your skin. Can cause sunburn, can cause skin cancer, and it can cause snow blindness. Well, not just snow blindness, any blindness. Snow blindness is, for example, you are skiing in the Alps, and there's a lot of sun, but there's a lot of snow. If you are skiing and you're not wearing any protection for your eyes, you can actually get partial snow blindness. But some of them can be temporarily, but of course it can also be permanent as well. So you have to be extremely careful. And if you're walking around in the snow in the winter, the sun is out, but there's a lot of snow on the floor. You need to protect yourself from that as well, because if there's a lot of sun and a lot of snow, you can get sunburn, and you could get blind as well from it. So you also need to take really big caution on when you're walking around in the snow in the winter, or when you're on the high mountains somewhere in the world. The Alps, Mount Everest, the Rocky Mountains in the United States, anywhere in the world, guys, take good care of yourself if you're in the sun. So this is it, guys, for today. So this is it for today. It is quite a long video. Spent a lot of preparations making this presentation. I am really sorry for acting very stressed in that, because it's extremely hot and I don't want to have to wear a vest while I'm making videos, because I don't feel it's actually appropriate to do so. And so yeah, so guys, we got more videos coming up. I can't promise you I'm going to upload tomorrow, maybe in the 2 days, or maybe in the 3 days, maybe more, I don't know. But very likely I could upload tomorrow. We'll see. So guys, don't forget to hit the thumbs up, like, subscribe, turn the notifications on, and that's it. So thank you very much again for watching, and I'll see you all in the next video. So take care, guys, and have a wonderful evening. Cheerio.